So today we're going to be talking about Cisco Zeus, monitoring as a service, your one-stop shop for real-time logs and metrics monitoring. I'm Jeff Birnbaum, product manager. Also joining me is Mark Solanas-Tare, one of our founding engineers sitting up here in front. And before I get started, I'm going to ask people if they could go to this URL and complete our survey to learn a little bit more about you. The first 20 people who complete the survey at CiscoLive will be getting our premium gift, this 6.6 amp hour power pack. So please make note of the URL, fill out the survey, and we'll be giving some of these away today and then more tomorrow at our workshop. And also we have a Spark room if you have questions. Here's the URL to get into the Spark room. You might want to enter that in your browser. And if you have questions during the presentation or afterwards, we'll be monitoring that Spark room for your questions. Okay, so today we're going to talk about monitoring of telemetry, metrics, and logs from various systems. We'll start by talking about the current market situation and user needs. We'll talk about the Cisco Zeus solution for ingesting logs and metrics. We'll show you a demo of the product, and then we'll conclude and have time for Q&A. Okay, so today, lots of devices in your infrastructure are generating logs and metrics from private and public clouds to VMs, containers, applications, IoT devices. So there's lots of data coming from lots of different sources. And the issue is, how do you make sense of all that? And the issues we hear customers talking about is they're constantly getting more and more data they need to capture and analyze. So it's like a continuously growing issue. It's not always easy to make sense of the data in terms of interpreting what it means. And customers don't necessarily want to stand up their own monitoring system and have to maintain that. So that's another pain that customers have shared with us. And finally, customers want to be able to monitor wherever they have their infrastructure, private, public clouds, equally easily. So translating into requirements that we see from the field is people need a way to quickly troubleshoot problems and reduce mean time to repair. They want to detect issues before they impact customer service to prevent customer-affecting problems. They want to use their metrics and logs to optimize their infrastructure and not over-provision. And similarly, they want to be able to plan for future growth. They want to see if certain infrastructure is being maxed out and being able to plan accordingly on growing that infrastructure. And people want a all-in-one solution that captures logs and metrics from all types of sources, so they don't have to search from different point solutions to get their data. They want to be able to capture data from all sources, public, private clouds, and ideally, they'd like to have a hosted service so they don't have to stand up their own infrastructure for doing that, which is why we came up with Cisco Zeus. So what is Zeus? We call it an IT operations analytic as a service platform. It lets you collect, store, analyze, display, and generate alerts on both logs and metrics. And the reason why we came up with this solution is our customers are challenged with gathering this data at scale from Cisco products. And there are a lot of third-party vendors out there that will help you with logs and metrics. So why not have a Cisco product to take care of that? So thus Zeus was born. And our target market, primarily IT operations, people who have to monitor and scale their infrastructure. But interestingly, a lot of our early adopters are developers within Cisco who are writing their code and generating their own log messages, and they want to look at that to help optimize their development process. And also, security operations people find benefit in our product, and you'll see in the demo a lot of security-oriented issues that we can uncover. And we are a Cisco InfoSec approved product. And we even had one team at Cisco that was using us for analyzing trouble ticket data. So any type of business data analysis it's possible to do with our tools. So how did we do this? We built our product primarily on open source tools, and I think you'll recognize some of them when you see the screenshot and the demo. But we also added our own unique features, and I'll explain that. And then we provide the interface you need, a web UI for browsing the data, a REST API for interacting with the system programmatically, and we have our own client software written in various programming languages to help facilitate getting your logs and metrics to our system via the API. So summary, the primary features of Zeus. One is logs and metrics analysis in one system. So you don't have to have a system for logs, another system for metrics. We can do it all in one system for you. We let you ingest data from your infrastructure and IoT devices via open source agents, calls to our API, or you can use our Zeus client as an intermediary to call our API. And as I mentioned, we have that written in various programming languages, Java, Go, what are the other languages? For the Python and Ruby, right. So in 4 languages, we have our Zeus client. We let you use open source tools like FluentD and CollectD to collect the metrics and logs on Linux-based systems. Also, when you sign up for a Zeus account, you as an administrator can create sub-accounts, so multiple users in your organization can log in and see their own data. And the way we let users see their own data or have multiple users share a pool of data is with a structure we call buckets, and I'll show you a little bit about buckets in the demo. And we also let you create alert messages based on logs and metrics. As the logs and metrics are coming into our system, we will look at them and let you match patterns or see if a metric exceeds a threshold and create an alert from that condition. And we let you integrate with a host of third-party tools with our API. In particular, Mark is going to be hosting a workshop tomorrow and Thursday at 10 a.m. in the DEVNET area here, specifically about integration with TensorFlow. So where does Zeus fit in? On the left side in yellow would be a typical system you need to monitor. If it's Linux-based, you can install FluentD and CollectD, and we have a default config file you can use, and we have various solution guides on how to tweak that for different applications. Or if it's not Linux, but you are running Java on that system, then you can send data to our Java client, which would in turn use the API calls to send it to us. And also, as I mentioned, we'll let you interface to any third-party tool using our API, TensorFlow being an example, any security systems you have or any other application performance monitoring systems you have. We can take data from that, or we can take data that we analyze and condense and let you bring that into another system. And we provide a web UI for browsing your data. We also provide a web interface to our API. We have a Swagger page. I'll show that also today. Let me just step through some screenshots. We'll go into more detail in the actual live demo, but this would be our home page. When you log in, this is what you see. We have a log subsystem for looking at your log data, metric subsystem for your metric data. We have a subsystem for defining and viewing your alerts, and then the admin subsystem The title here would be the name of your account, and from here you can create users, create buckets, and assign users to buckets. So here would be a typical screen to show you what users you've invited and which ones have accepted your invite. Here's a screen where you would create a bucket, and this lists the buckets you created. And for every bucket, we have a 32-character token, and you'll use this in the API and in your open source client when you send data to us. And once you create buckets, then for each bucket, you can assign permissions to different users based on what you want them to be able to see. So by default, Monkey is the admin. He has access to everything, but then other users, you can restrict what access they have to that bucket or not grant them access at all. And this is a screen where you can define an alert condition. When an alert condition is met, you'll get an email that tells you what happened, and also the system keeps a list of all the recent alert conditions that have been triggered. And of course, we let you browse your log data. If you've used Kibana, has anyone here used Kibana or Elasticsearch? Is that a product you've used? Okay, great. So this should be familiar with you. And then also, we'll show some dashboards based on both log data and metric data. And here's a screenshot of our Swagger page. I'll step through that during the demo. And let me talk about the demo I'm going to show you today. We set up a VM on AWS, and we have our own chat server application that simulates users sending chat messages, and that application generates logs. We'll take a look at that and see how you can visualize that. We have the CollectD open source agent collecting all sorts of system level metrics. I'll show that. Syslog, of course, everyone wants to collect syslog data. I have some interesting syslog dashboard I'll show you. We add an Nginx server to this VM, and I'll show you some Nginx dashboard, and also NetFlow. We have lots of NetFlow records, and both the Nginx access and NetFlow records we enrich with geolocation data. So there's a standard plugin for FluentD that lets you add this data, and you can get it from a free database, and that definitely makes it nice to visualize where your traffic's coming from and going to. So let me power up the demo. Oh, okay. Okay. So I'm going to log into our demo system. And since I'm not monitoring my screen, I'm going to have to twist my head here. Okay, and this is the home page that I've showed you before. I'm not going to go through the alerts in the admin. Let's just focus on the logs and metrics in the live demo. And I'll start showing some log dashboards. And the first dashboard we're going to look at is one I call all logs. So when logs come into our system, they get tagged. And this table here is showing all the different tags and how many logs we got for each tag. And the most numerous one would be syslog, because we're collecting about one syslog every 10 seconds. So a lot of syslog records. But also we have lots of NetFlow, but we also have lots of syslog records, in particular syslog's records related to the auth service. And here's a histogram, and then we can aggregate things by different tags, so you can see how many of each tag are coming in a particular period of time. And then below here, we actually have the logs themselves. And this would be a NetFlow log, and when you expand it, you can see the various fields you'd expect in a NetFlow log, source and destination IP and port, plus also the geolocation data that we added. So let's actually go first to syslog. So in the syslog, this is the total number of syslog records that we've collected over the past 15 days. And what we have here is an aggregation of the most popular syslog messages. So if the message field is identical, then we'll have a count of how many of those messages. And the most populous one is this excess permission or bad ownership, which is a known bug in OpenSSH. It has to do with the SSH, OpenSSH writing to a particular file it doesn't have permission for. But what's interesting is typically SSH is going to send data to this file if there are bad passwords received. So the fact that this number is so high is an indicator something's going wrong. And if you look at the other syslog records, they have a lot to do with connections being disconnected. And I can tell you none of these IP addresses are IP addresses. These are all from uninvited guests. We have no web firewall in front of our VM. So public IP address, people find it and they start hitting on it. And so these are all of the SSH related messages. And specifically, I created a similar dashboard that was just looking at authentication issues. And here's that dashboard. So it's basically identical to the one you saw before, but I add an additional filter which said, look for the text string identification anywhere in the log record. And now you see they're all related to the auth service, and they're all related to people trying to log in without the right credentials. So, 625 of those. And if you zoom in here, we can actually zoom. We'll give it a second here. Ah, there we go. I'll zoom in a little more. And once that comes up, you'll see that in this case, they're all from the same address, this 218 address. I looked it up. It's someone in China. And basically, this one hacker or his bot was trying to log in from the same address but multiple ports. So they're all coming into the SSH port but coming from different ports. So obviously, this can be very useful to security operations people to be able to see all the attacks on your infrastructure. And let's go look at Nginx access. So I created this other dashboard. And what this is going to show is all of the Nginx access records that we've received. And we'll just have to wait a little bit here, or I can just refresh the screen, see if that does anything. Yeah. The network is slow? Yeah. OK, here we go. So originally, when I planned this demo, I thought, well, we can just generate traffic from different IP addresses using Site 7x24 and show the pretty tile map based on the geolocation information we added to that. But actually, all this data, or 99% of it, is not data we generate. Again, it's uninvited guests who saw the IP address, saw that there's a web server there, and started opening up port 80. And so in this time period, we had 301 accesses, but from 45 different IP addresses. And we have a sort here by which IP addresses are sending the most accesses. And these first two definitely are not our IP addresses. If you click on one of them, it'll automatically filter on those. And let me open up. Oh, let me log in again. Okay. So we're back where we started from, and let me expand this out here. Whoops. I'm not used to using the mouse, and well, that's okay. We can just look like this. So what's important, what's interesting here, this person is using a head command, which means he doesn't want to actually get the data. He just wants to know if the data exists. And he's looking for all these PHP files. So obviously this is an attack, trying to see if we have PHP running and wants to hack in through one of the PHP files. So again, this is very useful for Security Operations Center. They can quickly drill down and see who's doing what in your network. Any questions so far? Okay. And let me go to NetFlow. Now, NetFlow, we have more NetFlow logs than anything else. But what I've done is I'm just looking at NetFlow from the past 5 days. That is when we started attaching the geolocation information to all those records. And what's obvious here is most of the traffic is coming from San Jose, California, and Boardman, Oregon, which is what we expect because these addresses are actually, the San Jose addresses are Cisco addresses on our private network on AWS, and then the Boardman, Oregon addresses are AWS's public IP addresses. So all of this traffic between Boardman and San Jose, and then this spike of traffic here, when I zoomed in, I found out it was from the loopback address. So when I filter out all that boring stuff, which I did, and I created a new dashboard that I called NetFlow Not From Us. And again, this is the same dashboard, but I applied some filters. And now we can see specifically traffic from unwanted guests. And as expected, the vast majority are directed at port 22. These are the SSH attempted intrusions, and the second most populous, I think, is port 80, right? So now everything here are hackers and bots who are trying to compromise our network. Again, something security personnel would be very interested in, and it's very easy to create these dashboards. You just have to create a filter to know what type of logs you're looking for, and then you go ahead and create a visualization, add it to the dashboard. And one final dashboard I wanted to show is for our chat server application. And the one interesting thing on the chat server application is we know it's a poorly formed application. Basically, what this application is doing, it's emulating chat users, it's opening chat sessions, and unfortunately, it's not closing them. So what happened here is our engineer started this application, shut it down when it reached 18 sessions, and then started it up again until it got up to about 63, and then shut it down because it consumed all the memory in our VM. And then these visualizations are just showing who are the top users and what are some of the top messages they sent. So again, once you have the data, it's pretty easy to visualize in various ways. But what's interesting here is correlating this to the host level metrics. And if I do that, if I look at our host level metrics here, and I built a dashboard specifically for the time frame that chat server application was running, and you can see the amount of memory consumed pretty much mirrors the number of chat sessions. We went up to 18, then we shut down the application, free memory came back, and then we started the application, and at the same time, it reached 63 chat sessions. We maxed out of memory, and you can see we had 0 memory here, and then it took a little while before the memory was recovered. So here's a way you can see how what is visible through metrics at the system layer can be correlated to metrics that we capture in the log data at the application layer. So again, a way to help you troubleshoot problems. And then the final aspect of our demo I wanted to show is our Swagger page. And basically we have API calls for defining alert rules, for sending and retrieving log data, for sending and retrieving metric data, and then for viewing which alerts were triggered. And I already opened up one of these calls, and all you need to do is insert the 32 character token, and in this case the name of your log, and hit try it out. And in this case, I used the API previously to send a couple of logs with a tag of JB, and then the get call is showing the logs that I sent. So you would just use our Swagger page to test the API. Once you're comfortable with that, then you can call it directly from your program or call our client, which in turn calls the API calls. And that's what I had for the demo. And okay. So to sum things up, we're an integrated solution. We let you monitor all the layers of all your infrastructure and applications, and we let you capture both the event or log data and the performance or metric data. We have security in mind. We have encryption between our service and the systems you want to monitor or our web interface. And we have the role-based access control through our buckets. The system's easy to consume. You don't have to stand up your own infrastructure. Right now, you request a free beta. We send you an email. You create your credentials, and you're in. And we're a hybrid solution. We're designed to work with public clouds, private clouds, or IoT. Anything that can create machine data, we can capture that data. And here's some contact information for us. The web page where you can request a beta account. We have a page on the DEVNET website. We have a support website with various product guides and solution guides. So if you want to learn how to monitor various open source tools using our product, we have that spec'd out in detail. And you're welcome to follow us on Twitter. And as I mentioned earlier, we are giving away the power banks for the first 20 people who fill out a survey. Just let us know more about who you are and your experience with logs and metrics. And please tell us how you liked our presentation by completing the CiscoLive survey. And that is it for my presentation. Do you have any questions? Ask us anything. We'd like to answer any questions you have about Cisco Zeus. So, question? Yes.
Electsearch and Kibana.
Yes.
That framework. So compared to that framework, what's the difference?
Okay. So the question is, how are we different from Elasticsearch and Kibana? That's a good question. Well, Elasticsearch and Kibana don't provide the role-based access control. This whole concept of buckets is our value add. That is our own proprietary design. So that's number one. If you want to be able to have multiple users in one account and let some see some data, some see other data, you can't do that just with Elasticsearch and Kibana. Elasticsearch and Kibana, you just have one bucket. It's not called a bucket, but everything is treated as one big mass. You can't segregate your data. In addition, we're collecting the metrics, putting in a time series database, and we're letting you visualize it in an open source tool that's designed for time series data, Grafana. But again, if you stand up Grafana and a time series database, you won't have that granular access control, which we provide. And plus, you would have to stand it up yourself or look for another company that provides that as a service. Any other questions? Okay. Well, thank you very much. Please come to our Spark room if you have any other questions afterwards, and very much appreciate your attention. Thank you.